Okay, we're on lesson 3, which is on experimental probability. So in the last lesson, we learned about theoretical probability. Now we're going to learn about experimental probability. And to do that, we're going to play the spinner game again. So if you are at home, you can do this on your own. So you can grab a paper clip and set it up just like we did in lesson 1. And spin the spinner. You're going to spin the spinner 15 times and record the outcomes. So you're going to spin once and then twice, add those two values up, and then go to the second turn, right? So the goal of this is saying that if the sum is greater than or equal to 5, then the student will win a prize. But for our experiment, we are just trying to get as many results as we can. So I'm going to let you do that. When you're all set with that information and that collecting that data, you're going to answer the follow-up questions on the next page. And all of those will be different based on your numbers, so we are not going to go over those together. But we are going to briefly just talk about the bottom 2 questions. It says, name a sum that would be impossible to get while playing the game. Well, the most you can get on the spinner is 4. So if you spin 4 twice, so 4 plus 4 would be 8. Anything greater than 8 would be impossible because there's no numbers that are going to add to a value greater than 8. What event is certain to occur while playing the game? Well, the smallest value you could get is 1 and 1. So you could add those up, you'd get 2. So you would have to have a sum of at least 2. So anything such as 2 or greater would be possible until you get to the 8. Right, next page. Okay, so this is what we just did was create an experiment to help us understand experimental probability a little bit better. So experimental probability is what does happen. So it's the actual results from the experiment, whereas theoretical probability was just us theorizing what we were going to get. It says the number of times desired outcome is going to occur over the number of trials that were in the experiment. Okay, so it says, what is the experimental probability of landing on a 4? So if I take a look at what we have, all of our outcomes, we've got 1, 2, 3, 4, 5, and 6, and we rolled the die a total amount of 27 times. Okay, I've got that because I did 4 plus 5 plus 6 plus 1 plus 5 plus 6. And in total, we get 27 trials. So if I want the experimental probability of landing on the 4, I'm going to write my probability sentence just like I did. Probability of 4, because I take what they're asking me and plug it in to the parentheses, equals. So the number of desired outcomes. So probability of landing on a 4, well, here's my 4. It landed on 4 only 1 time. So that would be 1 out of the total amount of trials that we did, 27. What is the experimental probability of landing on an odd number? So this time we're figuring out probability of the odd number. So I'm going to look. I've got 3 odd numbers, 1, 3, and 5. So whenever I'm figuring out all of those, I have to add up all those trials. So 4 plus 6 plus 5 give us 15. So the probability of an odd number equals and then we're going to simplify. So 15 over 27 becomes 5 ninths. Okay, what is the experimental probability of landing on B? So I'm going to take a look at B. They have 2 trials, and I'm going to add up 12, 2, 5, and 7. In total, there are 26 trials. So the probability of landing on B equals 2 out of 26. And I'm going to simplify 1/13. Okay, what is the experimental probability of landing on a vowel? So the only vowel here is A. So the probability of a vowel equals, and there are 12 trials that landed on A out of the total 26. And I'm going to simplify.
I'm going to get a scratch-off ticket on the way home. You know why? Quinn.
All right. So now just a little thought section. So what happens with more trials? Well, the more trials that there are, the more accurate the probability is going to be. So the more trials there are, and I guess not, the more realistic the probability. And how do the probabilities compare? Well, the probabilities that we're talking about to compare are the theoretical versus experimental. Theoretical is based on what we expect to happen in one trial. Experimental is what does happen when we conduct multiple trials. Okay, next page. So we're going to take a look at this chart here. So it says a student brought a very large jar of animal crackers to share with students in class. Rather than count and sort all the different types of crackers, the student randomly chose 20 crackers and found the following counts. Estimate the probability of selecting a zebra. Okay, so here are all the different animals that the student pulled out of the jar, and that's how many that they got of each animal. So if I want the probability of a zebra, I'm going to look and find zebra. There are 3 that came from them pulling them out of the jar. So 3 of them were zebra out of the 20. And we cannot simplify that, so that would be my final answer. Okay, so I'm going to have you try 1, 2, and 3, and 4. So this page on your own. So read them carefully, write the whole probability sentence, and also simplify your fraction. So our final answers should be fractions. So please pause the video, try it out. When you're all set, unpause the video and check your work. Okay, so probability of a lion equals 2 out of 20, or 1/10. Probability of a monkey is 4 out of 20, or 1/5. Probability of a penguin or a camel, so we're going to add up all of those trials. So 4 out of 20, or 1/5 again. And the probability of a rabbit. Well, there were no rabbits taken out of the jar, so that would be 0 out of 20, a probability of 0. Next page. It says, is there the same number of each kind of animal cracker in the jar? Explain your answer. Okay, but we're going to say that there's probably not the same number here. because we cannot assume they all have the same amount. We don't have enough information, and we don't know the proper totals. Oops, I forgot some words. Have the same amount. And all of our randomly selected crackers have differing numbers. All the selected animal crackers had differing amounts. If the student randomly selected another 20 animal crackers, would the same results occur? Why or why not? No, because each selection is random. They're not looking to grab a specific thing. We don't know the specific totals each one has in that jar, so everything is randomized. All right, that's all for this lesson. Good luck on your homework.